Okay, let's unpack this. You're working with Node.js,
Hmm.
and it's great for handling lots of connections,
Yeah.
especially I/O, right? Waiting on databases, API.
Exactly. It's built for that asynchronous waiting. But just because it can handle it doesn't mean your app is actually, fast.
Right. True mastery means pushing performance, reducing latency, managing resources properly.
Absolutely. If you're aiming to be an expert developer, performance optimization isn't optional. It's about building robust, efficient applications, making code work well, not just work.
So let's say your app feels sluggish, you think there's a performance issue. Where do you even begin?
You need to look inside. It's called profiling. Basically, getting a view of what your code is doing while it's running.
Finding the bottlenecks.
Precisely. Finding out where the time's going or where memory's being maybe wasted.
What tools do we grab first?
Well, a good starting point is the built-in NodeJS inspector. You can often use it with Chrome DevTools, which many people already know.
Familiar ground.
Yeah. It has a CPU profiler to see which functions are eating up time, finds those unexpected hotspots, and a memory profiler for, well, memory issues, potentially leaks.
Okay. And I've heard people mention clinic.js.
Oh yeah, Clinic.js is fantastic. It's open source. Clinic Doctor gives you a kind of general health check.
Right.
Then there's Clinic Bubble Prof. That one's really clever for visualizing async operations, helps untangle where time is spent waiting or processing an async code.
Async can be tricky to visualize.
It really can. And Clinic Flame generates these interactive flame graphs, great for spotting CPU-heavy functions by looking at the call stacks visually.
And for production environments.
Then you're often looking at commercial APM tools, application performance monitoring, things like New Relic, Dynatrace. They give you much deeper, continuous monitoring.
Okay, so we run these tools. What kind of problems typically show up? What are the usual suspects?
You often hit a few common bottlenecks. One big one is CPU-bound code. Code that's doing really heavy lifting, lots of calculations, complex synchronous processing. Since Node runs your JavaScript on a single main thread,
If that gets busy, everything else waits.
exactly, it blocks the event loop. Which brings us to event loop blocking itself. It's any synchronous task, really, CPU heavy or not, that takes too long and stops Node from handling other events. Makes the app feel unresponsive.
And even though Node's good at I/O, waiting is still waiting.
Absolutely. That's your IO-bound bottleneck. Node handles the waiting efficiently. Sure, it doesn't block the thread while waiting for the database or a file, but the duration of that wait still adds up for the user.
Makes sense.
And sometimes, even if individual IO calls are fast, doing tons of them very quickly can actually overwhelm things too.
Right, too much back and forth. And then there's the dreaded memory.
A memory leak, yeah.
Right?
That's when your app allocates memory, uses it, but then forgets to let go of it.
So it just grows and grows.
Over time, yes. Usage climbs, performance degrades, and eventually it might crash.
That touches on V8, the JavaScript engine, and its garbage collection, doesn't it?
It does. V8 has its garbage collector, the GC, which automatically cleans up memory that's no longer needed. It's generally very smart.
Yeah.
But sometimes, to do its job, it has to briefly pause the execution of your JavaScript. Those are the stop the world pauses. Usually short, but they can add up or cause noticeable jitter.
Can you see when that's happening?
Yeah, for deep dives, you can use flags like trafac. It spits out detailed logs about GC runs, pauses, and memory reclaimed. Pretty advanced, but useful.
Okay, so we've used the tools, maybe found a CPU hog or a memory leak. What do we do? Caching seems like a big one.
Caching is fundamental. Store results you've already calculated or fetched, right? Avoid doing the work again.
Different kinds.
Sure. Simple in-memory caching, just using a map or an object in your node process. Quick, but specific to that process.
Okay.
Then external caching using systems like Redis or Memcache. These are separate services, so multiple instances of your app can share the same cache. Very common.
And for web stuff, browsers can cache too.
Definitely. HTTP caching. You use HTTP headers like cache control.
Yep.
Tells browsers or CDNs or proxies how long they can store a response. Huge performance win, saves your server a lot of work.
What else is in the optimization toolkit?
Several things. If you're dealing with large amounts of data, use streams. Process data in chunks. Don't load everything into memory.
Prevents memory blowups.
Exactly. Always look at your database queries. Often the slowest part. Indexing, query optimization. Crucial.
Load balancing.
Yep. Load balancing, spreading requests across multiple node processes or servers, essential for handling scale.
And just writing better code.
Yeah. General code optimization, better algorithms, avoiding unnecessary loops or computations. It all adds up. Oh, and keep your dependencies updated. Sometimes performance fixes come just from updating a library.
So it really sounds like optimization isn't a one-and-done thing.
Not at all. It's a cycle. Measure, identify the bottleneck, apply a fix, measure again, see if it worked, keep iterating.
It's a continuous process of improvement.
Precisely. It's how you build applications that are not just functional, but truly performant and scalable.
And, like you said, a key sign of a developer really leveling up their skills,
Mm.
moving beyond just making it work.
It really is that step towards, deeper expertise, understanding the how and why of performance.
So, thinking about the kinds of applications you might be building or working on, what aspect of optimization feels most critical right now? CPU.io memory, something for you to think about.